In this lesson, we will be adding and subtracting rational expressions, as well as simplifying complex fractions. The first thing we're going to quickly review is adding and subtracting with like denominators. Notice in our first two fractions that we're adding, we have a similar denominator, so we know that we can add them together. Keeping the same denominator, we just add the numerator to get a plus b on the top. In the next example, we also have a common denominator of 8 this time, so we know that we can just add the numerators, 2 plus 5. Simplifying, we get 7/8. This should be simple review. In the next example, we'll take it to the next level, adding and subtracting with like denominators, but of rational expressions. So we notice that we have a 2x in our denominators, so we know that we can add the numerators or subtract them, keeping the same denominator. So we have 3 minus 7. Simplifying, we get -4 over 2x. Notice now we are only multiplying and dividing all of our terms, so we can now simplify this. We know that there's a 2 in both our numerator and denominator, so we're left with the -2 on the top and a 1 on the bottom. So this will simplify to -2 over x. In the next example, we have a common denominator of x minus 4. So once again, we can just combine the numerator and the denominator. 3x plus 6. Notice there is no more simplifying to be done here, so that would be our final answer. The next thing we're going to cover is finding the least common denominator for fractions. So we have a c here and a d here. They have nothing in common, so all we can do is multiply them together to get a least common denominator. So we'll get CD for our least common denominator. And the first thing we want to do is look in our first fraction. What are we missing in the denominator to get us CD? Well, all we did was multiply by d, but if we do that in the denominator, we also have to do it to the numerator so that we keep the same fraction. So now we have AD in the numerator for our first fraction. And again, we have to look over here. What are we missing in this denominator to get us CD? Well, we just multiplied that by c, but no, we have to multiply the numerator and the denominator by the same value to keep the value of the fraction. So we just get BC, combining the numerators with our like denominator. That will be our final answer. Similarly, when we're subtracting, notice CD will be our least common denominator once again. We're missing a d in our first fraction, so we'll just get AD in the numerator here, minus, we're missing a c in our second fraction, so we'll get BC here. So we're going to step this up a notch and apply it to our rational expressions. So the first thing we want to do is make sure that we have our fraction denominators in simplest form to find a least common denominator. So what we have here, 4 over 3x cubed, is in simplest form. We cannot factor that any further, so we're going to leave it be. But in our next fraction, we keep x in the top, the numerator, but we'll factor this. So notice we can take a 3x squared out of both of those terms to leave us with 2x plus 1 on the inside. We know how to factor, so that shouldn't be too difficult. Now what we need to do is find a least common denominator in these two terms. So we have a 3x cubed here and a 3x squared here. So we know that we'll need at least a 3x cubed for both fractions. But we also have a 2x plus 1 in this one and none over here, so that is going to have to be multiplied by our 3x cubed. So this is going to be our least common denominator, or LCD. So what we need to do now is, just as we did in the prior slide, what are we missing from this fraction in the denominator from our LCD? So we have 3x cubed here, we have a 3x cubed here, but we're missing the 2x plus 1. So we're going to take the numerator times that 2x plus 1 to give us the common denominator on the bottom. And in the next fraction, what are we missing to get a 3x cubed times 2x plus 1? Well, we have a 3x squared and a 2x plus 1, so all we're really missing is an x. So we're going to take the numerator times that x to give us the least common denominator of 3x cubed times 2x plus 1. Now that we have this, we can combine the numerators with our least common denominators. So we have 3x cubed times 2x plus 1. Combining the numerators, let's multiply this fraction out. We get 4 times 2x plus 1. Oops, there's an x there. Plus, we know that x times x is x squared. So simplifying that down even further, we need to multiply and distribute this 4. So we will have 8x plus 4 plus x squared all over the common denominator, 2x plus 1. And I like to write this in standard form, having our biggest factor first. So we have x squared plus 8x plus 4 all over 3x cubed times 2x plus 1. And that would be your final answer in simplest form. So in this example, we will be applying the same idea, except for notice now we're going to be subtracting. So we'll factor our first denominator. So we're going to get x plus 1. Factoring this, we're going to get x plus 3 times x plus 3, also known as x plus 3 squared, minus 1 over, factoring the denominator in our second fraction, we're going to get x plus 3 and x minus 3. So now we need to look for our LCD, our least common denominator. To do that, we look at the denominator in our first fraction. We have 2x plus 3's, and we have in our second fraction 1x plus 3 and 1x minus 3. So our least common denominator, we are going to need at least 2x plus 3's and an x minus 3. We can also write this as, to save us some time and space, x plus 3 squared times x minus 3. So what we're going to do next is look in our first fraction. What are we missing in this denominator to make it look like our least common denominator? We have 2x plus 3's, but we're missing the x minus 3. So again, we're going to take the numerator times our missing factor of x minus 3 all over our least common denominator, which we know as x plus 3 squared times x minus 3, subtracting our next fraction 1 times. Now what are we missing here? We have 1x plus 3 and 1x minus 3, so we're missing an x plus 3 still. So we're going to take that times the numerator in our second fraction to get us something that looks like this. So what we want to do next is simplify the numerator because we want our fractions in simplest form. So we have to multiply and distribute in this first section. So we have x squared minus 2x minus 3. Subtracting still, distributing the negative 1, we will get negative x minus 3 all over our least common denominator of x plus 3 squared times x minus 3. And We now have to combine like terms because again we want this in simplest form. So we have an x squared. Negative 2x and negative x will give us minus 3x. And negative 3 and negative 3 will give us minus 6. All over our least common denominator of x plus 3 squared times x minus 3. And that will be our final answer in simplest form. The next thing we're going to do is look at a new term. We're going to be simplifying complex fractions. And what a complex fraction is a fraction that contains a fraction in its numerator or denominator or both. There's two ways of solving this, and I have them listed here, but I'll just read them aloud. One way is to simplify both the numerator and the denominator and then divide them, or multiply by the reciprocal. Another method would be to multiply the numerator and the denominator by the least common denominator of every fraction and then simplify. So I think that you'll find one method to be simpler than the other, but sometimes maybe you find that you have no choice. So we'll go to an example and I'll show you what we're meaning. So this is what a complex fraction looks like. Notice our numerator is a fraction and our denominator contains fractions. So the first thing we need to do is to get our denominator to have a common denominator between these two fractions. So if we remember from before, to do that, notice these have nothing in common, so we need to multiply them together to get x minus 4 times x plus 1. And then we need to look at our first fraction. What are we missing in the denominator? Well, we know we're missing the x plus 1, so we take our numerator, which is 1, times our missing piece, which is x plus 1. Adding, what are we missing over here? Well, we're missing an x minus 4, so we take the numerator times our missing piece, x minus 4, all over our common denominator. Now that is just the denominator of our complex fraction. So in the top, we still have 3 over x minus 4. No simplifying to be done there. So if you remember from previous lessons, we know that when we're dividing by a fraction, we need to multiply by its reciprocal. So we have 3 over x minus 4 times x minus 4 times x plus 1 all over, and we can simplify this to x plus 1 plus, distributing the 3, we have 3x minus 12. So the first thing we want to do is simplify this so that we're not canceling anything we know we're not supposed to be. So we will get 3 over x minus 4 times x minus 4 times x plus 1 all over, combining our like terms, we'll get 4x minus 11. Now what helps me is to put a parenthesis around this so that I know I can't cancel anything out of there because we're adding these terms. So then we can look at what do we have in common in our numerators and denominators that can be canceled. And we know that we have an x minus 4 in both the numerator and the denominator here. So we can cancel those fractions or those expressions out of the fraction. And we'll simply be left with, since we know we can't cancel anything else out, 3 times x plus 1 over 4x minus 11. And again, we want to get this in simplest form, so we must distribute this 3 to give us 3x plus 3 all over 4x minus 11. And that will be our final answer in simplest form. So as a review, we know that when we are adding and subtracting rational expressions, we must have a common denominator first. That is the most important part of this lesson. Common denominator. And also when we're simplifying complex fractions, you have two methods to choose from, and we only used one of them today, but like I said, you'll find one that's easiest for you. And remember that when we divide by a fraction, we have to multiply by the reciprocal. And that will be the end of the lesson.